In this video, we're gonna continue our discussion on trigonometric integrals. So we're gonna talk about how to solve integrals that involve powers of tangent and secant and powers of cotangent and cosecant. Okay, so uh, whatever techniques ang applicable for powers of tangent and secant can also be used for powers of cotangent and cosecant. Kasi these two pairs are analogous lang. Okay, similar lang sila. In the sense na they are grouped together kasi because of their relation in terms of their derivatives. Okay, so kumbaga for example, derivative ng tangent has something to do with secant. Kasi if we differentiate tangent, it will give us secant squared. Tama ba? Same with cotangent. If we take the derivative of cotangent, then that would be negative cosecant squared. Okay? And in the same way, ang derivative ng secant has something to do with tangent. Kasi if we differentiate secant, it will give us product of secant and tangent functions. Right? So, meron ulit tangent. Same with cosecant. If we take the derivative of cosecant, then it will give us negative cosecant and cotangent functions. Okay? So, merong cotangent. And similar with powers of sine and cosine, so these integrals take these forms. Okay? So, kumbaga, we'll still focus on the exponents m and n. Okay? So, it's either product ng tangent secant or product ng cotangent and cosecant. Pero ang determining factor is ang is a value ng exponents nila. Okay? Now, before we proceed to the main cases, yung mga relatively complex na cases, let's talk about some simple na mga cases. No? So, number one, if the powers are equal to 1, so kumbaga ang m and n, they are both equal to 1, then it's a very simple na trigonometric integral, no? So, product of tangent and secant lang or product of cotangent and cosecant, which are readily integrable because of our trigonometric integrals na, or I mean, formulas for integration of trigonometric functions, di ba? Product ng tangent and secant, its antiderivative is secant, right? Product ng cotangent and cosecant, its antiderivative is negative cosecant. So, automatic na for this case. Okay. Next, if m is any number, so emphasis on any number. So it can be any number as long as n is equal to 2. Or kumbaga, if ang power ng secant is 2 or power ng cosecant or exponent ng cosecant is 2, then it is also readily integrable. Okay? So, for example, tangent and secant na pair. So, tangent raised to m, secant raised to 2 or secant squared. So, basically, I just apply u sub. In this case, u is tangent x. Du is what? The corresponding du is secant squared dx, which is already present in the original integral. Right? So, after u sub, use power rule, then you have the final answer. Same with the pair of cotangent and cosecant. So, for example, cotangent raised to m times cosecant squared, then let u be equal to cotangent, its corresponding differential is what? Negative cosecant squared x dx. So, yung cosecant squared x dx is present originally in the integral, right? So, you just put negative 1 inside and then negative 1 outside para ma-neutralize. And then afterwards, power rule. Very simple. Now, or kumbaga, for any other values ng m and n, then we have the following guidelines. Alright, so first case or subcase, if you will. If m is any number and n is a positive even number greater than 2, so emphasis on greater than 2 kasi if it is equal to 2, then we have the previous na case, di ba? So if n is positive even tapos greater than 2, then what do? We isolate. If it is tangent and secant, then we isolate a secant squared na factor, or if it is cotangent and cosecant, then we isolate one cosecant squared na factor. Okay? And then we will use them later on to satisfy du after ng u sub. Okay? So, for example, for tangent and secant, so we have your tangent raised to m of x, secant raised to, this is initially n, right? So n here is represented as 2k to emphasize lang na it's an even number. Kasi if we plug in any positive integer sa k, then 2 times k is always a positive even number, right? So if you have, again, if you have integral of tangent raised to m of x, secant raised to 2k of x dx, then we can isolate secant squared. Okay, so kumbaga from 2k we subtract 2 so that we can isolate secant squared. Okay, so again from 2k, which is the power of secant, we subtract 2, right? So that we can isolate secant squared x. And then itong 2k minus 2, from here we can factor out 2. So we now have the product of 2 and k minus 1. Okay? So that's what happened here sa ito na portion. Okay? So from secant raised to, sulat ko sa taas. So from secant raised to 2k of x, 2k of x. So nag-subtract ng 2. Secant raised to 2k minus 2 of x so that we can isolate secant squared x, right? And then itong secant raised to 2k minus 2, we can write this as secant raised to 2 times k minus 1 of x. And then we have here secant squared x. And then lastly, itong secant raised to 2 times the quantity k minus 1 can be written as in this form. Ito. Okay. So, kumbaga, we separated the two factors, 2 and k minus 1. We can do that because, of course, of power of a power property, okay, from the laws of exponents. Alright? So, we now have tangent raised to m, quantity secant squared x raised to k minus 1, and then yung secant squared x dx. Okay? And then from here, so again, itong 2k is even. And then itong secant squared, we convert this to tangent using Pythagorean identity. Okay? So from secant squared x, naging tangent squared x plus 1. From Pythagorean identity. We do this so that the resulting expression or the resulting integrand is in this form. No, kumbaga, after we expand ito, kasi may maiwan na exponent, itong k minus 1, if we expand this one and then distribute tangent raised to m, whatever the value of m is, after the expansion, maging ano siya? Sum of powers of tangent times secant squared x dx. Okay, so let u be equal to tangent, du is secant squared x dx. Okay, so after everything, readily integrable na siya. After uh, we do this simplification or simplifying ng mga techniques. Okay, so again, yung secant squared x na na-isolate kanina, we will use it we use it to satisfy du. Okay, so this is now our working expression for tangent and secant. Okay, the same way can be, or the same technique can be applied for cotangent and cosecant. Okay, so same lang. Kasi if we let u, in this case, we let u equals cotangent x, then its differential is negative cosecant squared x dx. So we already have cosecant squared x, kulang na lang ng negative 1. So you multiply negative 1 inside, and then of course negative 1 outside to neutralize negative 1 inside. Alright? Ayan. So after converting secant or cosecant to their corresponding Pythagorean identity in terms of tangent or in terms of cotangent, expand lang kasi may maiwan pa na exponent depende sa value ng k or depende sa initial value ng exponent ng secant, di ba? So expand and then distribute tangent or cotangent, and then apply u sub, and then afterwards apply power rule. Okay, so let's look at an example. We have here integral of tangent raised to 5 of x secant raised to 4 of x dx. Okay, so this is first case, obviously, kasi power ng secant is an even number, a positive even number. Okay, so from secant raised to 4 of x, we isolate secant squared. Ayan. And then secant squared x, using Pythagorean identity, convert natin siya to tangent. Ayan. So from secant squared, naging tangent squared x plus 1. And then distribute tangent raised to 5. And then from here, just let u equals tangent for both terms, diba? Similar, same technique lang. U sub lang. Where du is secant squared x dx. Okay, so ayan na. We now have secant squared x dx already. Okay, and then just apply power rule. First term, this is tangent raised to 8 divided by 8. Tapos, second term, tangent raised to 5 tangent raised to 6 divided by 6. Then plus c. This is now the final answer. Next. So, case number 2. If m is positive odd number. So, kanina, m is any number, tapos n is positive even number. This time, ang m or ang power ng tangent or power ng cotangent is a positive odd number. And then n is any number. Okay? So, if this is the case, then we save or we isolate a secant tangent na factor. Or in the case for cotangent and cosecant, we isolate cosecant cotangent na factor. Okay? And then we will use them to satisfy du. Okay? Kasi in this case, ang focus natin is ang cosecant or ang secant. Alright, so let's look at the forms for these integrals. Ayan. Tangent raised to m initially. So m here is represented as 2k plus 1. So as to emphasize lang na it's a positive odd integer. Okay? And then secant raised to n of x dx. Right? So again, if this is the case, we isolate tangent x, we also isolate isang secant x na factor. Okay? So that's why we can see here an na-isolate na secant x tan x na factor. Okay? So again, from tangent raised to m, we isolated one tangent na factor. We also isolated or we factored out isang secant na factor so that we can form or we can group together secant x tangent x. Okay? Kasi later on, we will use this to satisfy du ng secant. Okay? So after we isolated secant x and tangent x, so this is now the remaining na factors. So from 2k plus 1, nag-subtract ng 1, kaya naging 2k ito siya initially, tangent raised to 2k. Tapos because of a power property, we can write tangent raised to 2k of x as, or in this form, no? Quantity tangent squared x raised to k. Okay? And then, of course, secant raised to n, nag-factor out tayo ng isang secant x na factor. So, mag-subtract ng 1 from n. Kaya naging secant raised to n minus 1. Okay? So, check lang natin later sa example. And then, from here, we convert itong tangent into its equivalent expression using the Pythagorean identity. So from tangent, we convert this to secant using Pythagorean identity. Okay? So again, add yan siya, 2k plus 1. And then yung tangent, convert to secant so that the resulting na form ng integrand is in what form? Sum of powers ng secant. Tapos if we let u be equal to secant, its differential is secant x tangent x dx. So readily, na siya. Kumbaga, integrable na siya. Okay? So yan, same for du. And then this is another working expression for this type of integral. Alright, so makita natin later on sa example. Same is true for the powers of cotangent and cosecant. Okay? So here, ang i-isolate natin is isang cotangent na factor, isang cosecant na factor. Okay? Kasi mag-let u, in this case, let u be equal to cosecant x. And then its du is what? Du niya yung negative cosecant x cotangent x. So, kulang lang ng negative 1. Okay? So, i-count lang later on ang negative 1 na factor. Alright? So, again, expand itong secant raised to, or I mean secant squared x minus 1 raised to k, whatever the value of k na maiwan. And also for cosecant squared x minus 1. Expand and then distribute yung naiwan na secant na factor. And then let u sub in general. And then afterwards, power rule. Okay. So, let's have an example. You have your cotangent cube x and then cosecant raised to the 5th power x dx. So here, power of cotangent is a positive odd integer or a positive odd number. Okay, so if that's the case, yan, we take out or we factor out, kumbaga we isolate one cotangent x na factor. So ayan, so from cotangent cube naging cotangent squared na lang. And then from cosecant raised to the 5th power, we also isolate one cosecant na factor. So ayan, kaya naging cosecant raised to 4 na lang. Alright? Then what do we do next? Itong cotangent squared na naiwan, we convert this to cosecant using Pythagorean identity. Alright? So, naging ganito siya. Cosecant squared x minus 1. And then, after this one, distribute ang cosecant raised to 4. Alright? So that the resulting integrand is in this form. Okay? Sum of powers of cosecant. And then we have here, initially we only have here cosecant x, cotangent x dx, diba? Pero if we let u, kasi, if we let u equals cosecant x, its corresponding differential is what? Negative cosecant x, cotangent x dx. Okay? So we already have cosecant x, cotangent x dx initially. So just multiply negative 1. Yan. And then, of course, neutralize by multiplying negative 1 outside. Okay? Then after this one, power rule na lang. So cosecant raised to 7 divided by 7. And then cosecant raised to the 5th power over 5. And don't forget the negative 1 factor outside. Alright? So that's now the final answer. Alright, so next subcase for powers of tangent and powers of tangent and secant and powers of cotangent and cosecant. So number 3, we have here, so if m, or the power of tangent or the power of cotangent, is a positive odd or even number, and if n, or the power of secant or power of cosecant, is 0, kumbaga if ang makita lang natin is tangent raised to a certain power or cotangent raised to a certain power, then it's case number 3, kumbaga. Okay, so what do? We convert a tangent squared, or in the case of cotangent and cosecant, we convert cotangent squared to secant squared. So kumbaga, our goal here is to arrive at an expression that is integrable. So be it using the first na guideline or the second na guideline. Basta, if this is the case, then we isolate tangent squared or cotangent squared, tapos use Pythagorean identity. And let's see what will happen. No? So basta ang goal lang, class, is make it integrable. Okay? So repeat the process if necessary, kumbaga. Okay? So ayan. From tangent tangent raised to m, we subtract 2 kasi we'll have to isolate tangent squared. And then from tangent squared, we use Pythagorean identity. Okay? Then convert to secant. And then, check natin if integrable na siya after. So, expand nyo siya. Distribute. Then, after that, you check if it is already integrable. Okay? Same with cotangent. Yan. So, let's look at an example. So, tangent raised to 5, obviously, we only have tangent na factor for this one. So, kumbaga, ang power ng secant is 0. Okay, so this is case 3. So, what do? We isolate tangent squared. Yan. So, from tangent raised to the 5th power, we now have tangent cubed and tangent squared. And then from tangent squared, so we convert this to secant squared using Pythagorean identity. Okay? Then, distribute and see if integrable na siya after. So, yan. Tangent cube x, secant squared x, first term is actually integrable na. Let u be tangent x, corresponding du is secant squared x dx. So, okay na ang du. Satisfied na ang du. So, we can already integrate itong first term. Ang problema is ang second term kasi it's not readily integrable in this form. Okay? So, we apply case 3 na method, na technique. Okay? So, we isolate tangent squared pa din. Ayan. So from tangent cube, this becomes tangent x, tangent squared x. Okay. Then yung tangent squared x again, convert to secant using Pythagorean identity. Okay. And then distribute. Right. So after this one, check ninyo if integrable na. So the resulting second term, itong tangent x, secant squared x is integrable na because if we let u be equal to tangent x, its resulting na differential or resulting na du is secant squared x dx, right? So, okay na. Differentiable na. I mean, integrable na pala. Itong tangent x, of course, we have a formula for integral ng tangent. Okay, so readily available na ang antiderivative ng tangent. Okay, so we can proceed with integration. So again, first and second term, just apply u sub u equals tangent x du is secant squared x dx for both the first and second term. Okay, and then afterwards, power rule. Okay, so itong tangent cube maging tangent raised to 4 over 4. And then itong tangent x maging tangent squared x divided by 2. And then of course, formula for, antiderivative ng tangent x is ln secant x. And then of course, plus c. Final answer. Now, what if kasi, di ba, in general, we have tangent raised to m of x secant raised to n of x dx, or integral of cotangent raised to m of x times cosecant raised to n of x dx. So previously kasi, di ba, previous na case, what if n is 0, tapos m is positive odd. Tama ba? Yan, positive odd or even number. And then power ng secant or cosecant is 0. That's the previous case. What if the other way around naman? Yung m naman ang 0. So that we can only see, or kumbaga we are left with secant or cosecant raised to n. Okay? Particularly if n is positive odd number. Okay? If that's the case, we can use integration by parts, which will be discussed in the next video. Or in general class, if n is any number, we actually have reduction formulas. No, I'm sure you've already encountered reduction formulas from your when you search for mga formulas, integration formulas. Okay, reduction formulas, these are they are a form of shortcuts, kumbaga. No, so we do not actually recommend using reduction formulas because, again, they are shortcuts. They are shortcuts and they take away the analysis na part of solving integrals. And yung analysis kasi, it's an essential discipline that you need to develop from solving math problems. No, that's why we do not recommend reduction formulas in that particular, because of that particular reason. No, kasi wala tayong analysis, kumbaga. And also, they are relatively difficult to memorize because they contain more than a few terms na prone to errors ang pag-memorize, no? If you cannot completely memorize them all. Of course, during exams, because we do not allow using formula sheets, then medyo mahirap if you memorize reduction formulas on top of the basic integration formulas that we already have, di ba? So instead of using reduction formulas, they are they are shortcuts nga. So as opposed to using reduction formulas, we have we have our basic formulas, no? So just follow the natural flow of solving integrals using your prior knowledge, using basic formulas, and using analysis, of course, right? And then, so these are just some reminders. Now, sometimes one guideline or one technique or one formula or one method may overlap. In other words, for a single integral ba, there are more than one applicable na technique or formula or method, then you just use whichever is more convenient, more comfortable for you. Okay? And whichever will lead to a much simpler na solution. Okay? Depende sa inyo. Now, when none of the aforementioned guidelines, this is particularly talking about our our current na lesson, no? Powers of tangent and cotangent. Yung previous din na lesson na powers of sine and cosine. When none of them applies or can be applied, then we can convert them to, kasi nga we are dealing with trigonometric functions, di ba? We can always try to convert them to sines and cosines, particularly if the given is in terms of tangent, secant, cotangent, cosecant. So we can always try to convert them to sines and cosines using the appropriate na mga identities. Kasi by experience, it's much more, kumbaga, it's simpler if we deal with sines and cosines as opposed to dealing with tangent, secant, cotangent, cosecant. Okay?